Number 21 is a log problem. Here we want to start by combining. You can see that we have logarithms on both sides of our equal sign, but we can't cancel the logarithms until we're down to just one on each side. If you'll remember from Algebra 2, whenever you have a minus in logarithms, this is the quotient rule. And with logs, minus means divide. So on the left side of our equation, we have log base 5 of 3x plus 2 divided by x. And then the other side stays the same for now. So making that combination there, subtracting means division in logarithm world, means that we can cancel our logs. So we have 3x plus 2 over x equals 4. And now this is just a little algebra problem. To get that x out of the denominator, we'll multiply both sides by it. And then it cancels on the left side. And moves to the right. So on the right, we have just 4x. Now we can move our 3x over. And we have x equals 2. You always want to make sure that your answer works in the context of the problem. So remember, we can't take the logarithm of a negative number. So if we look back at the beginning at our first step here, where our x's are, if we plug into both of those places, we don't get any negatives, so we're fine. If you were to plug in and get a negative, like if this whole thing was to turn negative, or this whole thing was to turn negative, or 0, then we would say that that is not a solution. But here 2 works. You always want to check for extraneous solutions no matter what you're doing with logarithms when you're solving. So make sure you do that. And if you get an answer that's not a solution, show it, but just like put a little line through it. So if 2 wasn't a solution, you would just put a line through it like that. But that's not the case here. 2 is a solution, so we're good. So this x equals 2 is our solution because it works when we plug it back in. Okay.
Made with Doodlecast Pro.